This is RD Sharma Solution Class 12th, Chapter 9. Continuity exercise is 9.2. So before we go ahead solving this exercise, there are certain things which you need to understand. There are certain intervals, closed interval and open interval, where the function will be continuous, where it will not be. So for open interval, if it is continuous, we write like this, round bracket a and b. So between a and b, that means every point starting from a till b, at every point this function has to be continuous without any break. Here the same thing goes for because we are talking about two intervals. So this is the closed interval, square bracket closed interval. So when the function is continuous in this closed interval, there are three conditions. The first one, that is, it has to follow that in open interval it has to be continuous. The second condition is this a and b. So limit a plus, that is from a and above. If you take the value of the function, it has to be fa, the value of the function at a. So this is the second condition. The third condition is the limit b and below, that is on the left of b. So limit b minus the fx, the value of the function at x, is equal to fb. So the closed interval and the open interval, the continuity will be subjected to or will be defined by the discussion we just had, right? So whenever we see that a function is continuous, there is a domain, that is, there are functions which are continuous everywhere, but like minus infinity to infinity, these are continuous and there has to be a domain. So this domain is continuous everywhere, but there can be some domains, say 0 to pi by 2 or pi by 2 to minus pi by 2. There are domains also. Okay, let us take the properties of the continuous function. For example, we have a function called, say, f. There is another function called g. More precisely, they are fx and gx. So when they both are continuous, then under some boundary or some domain, there are certain properties these two functions follow. That is, when you add these two, when you subtract these two, when you multiply these two, when you divide these two, when you multiply a scalar, say alpha or k, with any of the function, or division as I just indicated, or you can take 1 by f or 1 by g. The only last two, the g should not be 0 and f should not be 0, or gx or fx should not be 0. Okay, so when the function are added, when these two functions are continuous under certain domain, all these will be also continuous under that domain. Then we talk about composition, that is FOG and GOF, f of gx and g of fx. If fx and gx are continuous, then f of gx and g of fx, they both are continuous as well. They also follow the concept of continuity. Remember, f of gx and g of fx. Okay, so these are certain properties of functions which are continuous at certain domain. Now coming to there are certain functions which are continuous. So when we will discuss the question, you need to know that there are certain theorems. We don't need to prove it here, they are in the book. So modulus function or absolute value function, it is function, this modulus value of modulus is continuous if this fx is continuous. Then we have the continuous continuity for constant one, that is fx equals c, constant, 2, 5, 6, these are all constants. So it will be constant everywhere, this constant function. It will be actually a straight line. It is y equal to c, it will be a line parallel to x-axis. Then we have the identity function y equals x. This is the graph, or you can say straight line of this function. This is the identity function. This is also continuous everywhere. Along with this, we have, say, for ax square plus bx plus c. So this is a polynomial. So a function, polynomial function, is also continuous everywhere. So it can be a one order, two order, or multiple order function. So whenever we do the question, whenever this comes, polynomial comes, we'll directly say that okay, this polynomial is a continuous. So we need to see, and we need to just understand that these are continuous function. We don't have to prove it. Okay. So when fx and gx are continuous, what will happen? Fx and gx, because fx by gx, when we do, we need to know the domain of gx also. That is, they will be continuous but under certain domain. That has to be very clear. A to the power x is continuous, but the only condition is a should be greater than 0. Then continuity will follow. E to the power x, this is also continuous. When e to the power x is there, consequently log x will also be like that. So a to the power x, e to the power x, and also log function, log x function, this is also continuous, right? Okay. Coming to sine, cosine, and trigonometric function, you can say. So sine and cosine, they are continuous everywhere. Sine and cosine are continuous everywhere, but tangent is continuous but in certain domain, and you know that domain if you have done trigonometry properly. That tan, that has to be under certain domain. But when we talk about cosine, or this 1 by sine, 1 by cosine, 1 by tan, that is secant, cosecant, and then we have the cotangent. So they are also continuous, but we have to define, and we should know under what domain, right? When we talk about inverse, so inverse, when we know sine only goes from -1 to 1. So the sine inverse x, fx equals sine inverse x, this will be continuous when this is -1 to 1. So this is the interval. So this is a square bracket, and you know what kind of interval this is. Okay? Because this square bracket, this is closed interval where these are included, -1, 1 are included. Okay? So these are the basic things you need to know before attempting the exercise. Okay? So let us apply this. Starting with the first question. Prove that the function fx, which is sin x by x and x plus 1. So sin x by x, x is less than 0, and x plus 1 is x greater than or equal to 0. So x is the point of contention. When we go on the left hand side, it is sin x by x. On right hand side, it is going to be x plus 1. Okay, the first thing is, we have just discussed that we have to prove in this question that this is everywhere continuous. But what we discussed just now, that sin x is continuous. When we are talking about x less than 0, sin x is continuous. X is continuous, we have just seen now. So division, you can call that numerator as fx and the denominator as gx. So fx by gx, if gx is not equal to 0, then it is continuous. Okay? Fx and gx both are continuous. So this is what you have to write. You can call it as a quotient function because it is the form of f by g. Now coming to x greater than 0, x plus 1, fx is x plus 1. So when this y is x plus 1, this is a polynomial of first degree. And all the polynomial function, they are continuous, as we just suggested. So this, when x is greater than 0, we have fx equal to x plus 1. Therefore, fx is continuous at each x greater than 0. Now, the part which question is asking is prove that the function fx is this all x less than 0, x greater than 0 is everywhere continuous. But this thing with the way is same what we are going to do. We are going to find out the LHL, RHL and the value of the function at 0. So if they are equal, then it is continuous. You can very well prove that it is continuous at 0 also, because this is the point they are asking. So let us check the left hand limit and right hand limit. And since we have already defined it, that x equals to 0, left you go, it is sin x by x, right you go, it is x plus 1. So LHL is on the left, that is 0 minus h. RHL is 0 plus h. So the LHL will be 0 minus h, we'll take it as minus h. RHL is, we are taking x as 0 plus h, so you can take it as h. Now just put this minus h in sin x by x, x less than 0. X greater than 0, just put this as h. So this is sin minus h divided by negative. So we have negative h here. So negative h. Okay. Here we have this x plus 1. So you can just write h plus 1. You know that sin negative theta, sin minus theta is minus sin theta. So you can write it as minus h sin h divided by minus h, and minus minus gets cancelled. Now apply the limit. This also we know. Here also we will apply the limit. Limit h theta tends to 0, sin theta by theta is what? It is 1. Here also h equals 0. So it is 1. So left hand limit is 1. Right hand limit is 1. And what is the value of the function at x equals 0? We have to use x plus 1 here. So f0, just put it here. In place of x, replace it by 0. 0 plus 1 is x plus 1. I am replacing x by 0. So it is 1. So left hand limit, right hand limit and this one, the value, they all are equal. Okay. So you can say that this at 0, this function is continuous. Discuss the continuity of the function. Now you see here fx, x and mod x. You have to view them separately and then see, because we have these properties and attributes we just saw. So x equals to 0 is the point of contention. When we go on the left hand side, you have to take x by mod x. Mod is absolute value basically. So x by mod x. On the right hand side also you are going to use the same thing, because when x is not equal to 0, you have to use these. Okay. Now when we just go ahead, just see that is x by mod x. Fx you can call it as x, gx you can call it as mod x. And individually this x by x equals x, we have just seen that this is continuous everywhere. Also the mod x is continuous everywhere. Y equals to x is simply first order polynomial. And y equals mod x, which is the absolute value of x. And this function is also, we have seen that it is continuous. But there are points where it will not be continuous. And we'll check it at 0 here. Right? So let us see at this point on both of this. For that, what we are going to do? We are going to apply the left hand limit and right hand limit. LHL and RHL concept we have already seen in the previous exercise. We have done more than 44 questions. Okay. So we will just do the same concept here, but you may write as in given in the question that what is mod x. Mod x I have already shown you that mod x is x when x is greater than or equal to 0. It is negative x when x is less than 0. Right. So x is equal to 0 minus h at left hand limit. X equals 0 plus h at right hand. Let's just put this 0 minus h and 0 plus h. Okay. Let me write this, because we are using minus h and h, I am putting it here. Minus h divided by mod of minus h, here h divided by mod of h. Mod is absolute value, so positive h will come out. Here h by h, you can cancel it, it is negative 1, you can cancel it, it is going to be 1. Now what do you see here? The left hand limit and right hand limit, they are not equal. So when they are not equal, that means at 0, see, x is continuous everywhere. Mod x also we talked about that. But when we take x by mod x and we are specially checking at x equals 0, So it is discontinuous at x equals 0. So you can check the value also. It is already given at 0. The value is 0. So it is not -1, 1, 0. They are entirely 3 different values. It is discontinuous at x equals 0. Okay. But if you want to write more, because you can elaborate the things every time just to please your examiner, then what you can do? Mod x is x when x is greater than 0. Mod x is negative x when x is less than 0. And since the value of fx will at x greater than 0 is 1, we have found out. At x less than 0, we have found out it as -1. At x equals 0, it is equal to 0. That also we have shown, right? So this is how you can write to make the answer or your solution more effective. This is how we do the things. Okay. So this is one of the types of question, and there are questions coming which are of the same type. That is, we have multiple question of this 3.1, 3.2, etc. So find the points of discontinuity, if any, of the following functions. First concept is very clear. When x is not equal to 1, what we are going to do? We'll use this polynomial. X cube minus x square plus 2x minus 2 on both the sides. Because when x is not equal to 1, this is the, say, expression, or you can say the polynomial we are going to use. So this function is a polynomial and it is continuous everywhere. Then first you have to write that. So it is continuous at every point. It is everywhere continuous. And we will, since the question is that there are two things being given. Since x not equal to 0, this is given. But when x is equal to 1, it is already given that it is 4. So we have to check whether it is also saying the same thing. Because continuity, discontinuity, we have already seen. But when the question is saying that, okay, check it at when x equals to 1, it is 4, then say whether it is continuous or not. So LHL, RHL will do. We'll use 1 minus h because we have to check at x equals 1. So we'll just place x equals 1 minus h on the left hand side. And here we will put x as 1 plus h on the right hand side. So this is x cube 1 minus h whole cube minus 1 minus h whole square plus 2 into 1 minus h and minus 2. This is your LHL. And RHL, same thing. In place of x, just put 1 plus h. So 1 plus h whole square minus 1 plus h whole square plus 2 into 1 plus h minus 2. Now there are two ways. Either you open all these, cube and square, etc. But I'll just tell you the shortcut. Just apply h tends to 0 here only. Just make it as 0. You'll get the same answer. So 1 minus 1 plus 2 minus 2 here. So it is going to be 0. Right hand side, again apply h tends to 0. So 1 minus 1 plus 2 minus 2. Again it is 0. Okay. Now since we said, okay, it is continuous everywhere, this polynomial function, it is okay. Since the question is also saying that when it is x equals 1, that is f1 is equal to 4. It is given in the question itself. That means the left hand side and right hand side are meeting, but the value of the function at 1 is 4. So it is discontinuous at x equals 1. So the only point of discontinuity for this function fx is x equals 1, because the question has been formed in such a way that it is not continuous at x equals 1. This question we are going to see in the next discussion. Thank you so much. Take care of yourself.